Yeah, hello friends. Let me start recording on Zoom. This is Durga from ITversity. Those who are joining from YouTube, as you guys are aware, this is the backup for my live audience. So in case of any questions, if we could not answer immediately in the live chat, just bear with us. And let me proceed with today's curriculum. And no audio. Is it only with? Okay, just give me a moment. Can you guys hear me now? Can you hear me now? Hello? Yeah, I think now it should be fine. Can you hear me now? Okay, thank you. For some reason, it went on to mute. Okay, thank you. So let's get started. Let's catch up where we were last week. We were talking about developing applications using Python, and I have covered from JDBC perspective using Python shell, but I want to develop using PyCharm. And the reason why we could not do with PyCharm is PyCharm could not recognize MySQL dependencies. And I troubleshooted the issue and I got the solution. Now let me show you how to get the PyCharm working on your PCs. So here I'm with respect to MySQL. Here I'm launching PyCharm. Let me open other project Python demo. Let me just make sure that I'm in the right one. Yeah, this is the one which I was using last time when I tried to develop using PyCharm. MySQL.connector was not recognized. That's where we got stuck, and we used Python shell rather than using PyCharm. So the reason why it was failing is whatever pip we are using Cygwin is not integrated with the Python version and pip version which PyCharm is using. So we are using two different Python and pip versions through Cygwin and through PyCharm. That's where the confusion was. So the way you have to set up the MySQL connector so that you can access through PyCharm is you have to launch Cygwin here. So let me launch Cygwin. Once the Cygwin is launched, okay, I think PyCharm is launched on my PC rather than on the Windows machine. It got launched on Mac rather than the virtual machine in Windows. So I'm launching PyCharm once again here. This is the one which I have to choose, and it will take a moment to get launched on the Windows machine, and then I will show. Yeah. So now you can see PyCharm is launched on my Windows machine. Yeah, this was where we got stuck last time. I was trying to create an end-to-end application. I have created source main Python directory and also resources directory, and I tried to import MySQL.connector, and then it started complaining that it cannot identify MySQL. And we tried to set up using pip, and it did not work. So the way the reason is that the Python version which is being used by PyCharm and the version which we are trying to use using Cygwin is different. There are two instances of Python. One is being used by PyCharm, and the other one is used by Cygwin. When we launch Python shell on Cygwin. So that being said, the way you have to identify and run pip install MySQL connectors Python RF is by right clicking, by choosing the project, go to file, go to settings, go to project JDBC demo and project interpreter. You can see the path. The path of Python which we are using is C Python 27. There is a python.exe. So PyCharm is using that. So we have to go to that location on Cygwin. So cd sig drive c Python 27. Once you go to this location, there is a directory called scripts. You have to go to that scripts directory, and then there is a pip pip2 pip2.7, all of these things here. So you can use this pip. So you can say pip in this location, pip, and then install MySQL connector Python -rf, and then it will actually set up uh, MySQL connector for you. Okay, as it is already installed, it is saying it is already satisfied for me. In your case, it will not, and you have to use this dot slash in the beginning. Otherwise, it will pick the default pip. As we have to execute the one which is in this directory, we have to use this dot slash. Okay, so go to this location on your PC, wherever your PyCharm's Python version is there. Go to the scripts directory and run this command, and then it will be installed. Yeah, there's a typo, Sumit. That's why I'm pasting this. Okay, we'll give some time for you. Make sure we all install this. Once this is set up, you can launch the PyCharm and create the program and say import MySQL.connector, and you are good to go. Okay, anyone installed successfully and validated through PyCharm that you can access MySQL dependencies? Cool. So shall I move on? Anyone? Hello? So someone is not on mute. Let me mute all. Yeah, I muted all. Sure, Savia, you take your time. Uh, Uh, externally managed, not recognized. This one I need to see. So let me share. Let me stop sharing my screen. And Sumit, you can share your screen, and then we will see where the issue is. You can share your screen, Sumit. Okay, let me take the control. Okay, let me do this first. Pip install, upgrade, setup tools. For those who got error like Sumit, run these commands. I will paste in chat in a moment. Okay, so let me, Sumit, can you stop sharing the screen? Thank you. So I hope everyone got it. So we just need to upgrade the setup tools. Let me paste those commands in the chat. Okay, so pip install hyphen hyphen upgrade. After running these two, you can actually run the original command. Okay. So I forgot my Mac charger today due to battery draining down fast with this Windows machine. I will drop the Windows machine shortly, and I will try to use my Mac. That being said, we'll wrap up Python. The ones which we are talking about, or which I was planning to talk about after setting up MySQL and all, is already available in this course, Learn Python for Spark, along with the code snippet and the instructions. So I will highly recommend you to proceed with this and understand what I'm trying to do here. So one thing which you need to understand is if you look at application.properties, there's a category called dev. and then I have created DB username, DB password, DB hostname, DB name, etc. For production, there will be something like prod in the square brackets or whatever keyword you want to use for production. And then all the settings for that will be there as part of the resources file, same application.properties file, or in the same location on a different machine. It could be it could be anywhere. It could be part of the bundle. It could be separate also. Once you have created this application.properties, here I am loading that application.properties using config parser package. Okay, and then code is pretty straightforward. Only thing you need to understand is here I'm passing something as argument, and this is how you can pass arguments for Python program using sys package. There is a sys.argv where you can read the arguments, and here I am reading the first argument. If I say argv of 0, I will get the program name which I am trying to run. Argv of 1 will give the first argument which we are trying to pass. So here we need to pass dev as argument. When you pass dev as argument, it will go to this category and start reading these properties. Okay, so that's where here env is nothing but dev. When I say props.get env, which is dev, and db username, so it will go to the category dev and get the property db underscore username, property value of db underscore username, which is nothing but hr underscore ro, and that will be assigned to username. Same is the case with password, hostname, and database. Okay, so if we pass dev, we will get the dev properties. If we pass prod, we will get prod properties, whatever is the keyword you want to use for production. And then the way I have demonstrated earlier on Python shell, the same way, here we are actually creating the connection object, and rest of the stuff is pretty straightforward to understand. Okay, so go through it and set up the, try to create application.properties as part of the resources, and then program under source main Python, and copy paste this program. And once that is done, to run this using PyCharm, you have to go to the program, go to the run, and edit configurations. You have to go to the edit configurations. You can click on plus and give the details, or if you just want to get things auto-filled, you can cancel this one and then just say run MySQL demo. Okay, and now if you go to run and edit configurations, you will see that in the list. Otherwise, you have to give the name, you have to give the script which you want to run, and then you can pass the parameters. So in this case, I can pass it as dev here, and then we will be able to load the properties from the properties file, and then we can proceed with our application. So properties is the better way of organizing all the all those properties that needs to be changed for your application at runtime. So if you are familiar with any, if you have done any custom installations, even with tools like media player and all those things, there will be, if you recollect, once you download and once you double click, you will have custom, typical, and few more options, or advanced. There will be typical, which will be the first option, which will be default, and then you will have custom or advanced. So whenever you say custom or advanced, it will let you to customize few settings, and those settings will be preserved as properties files internally, and that will control the behavior of applications such as media players. Same is the case here. So for externalizing the properties using Python, this is the approach which we need to follow, and the package to load the externalized properties is nothing but config parser. Okay, and then we will limit the arguments that needs to be passed to the program to one or two values. More, we shouldn't pass many arguments at runtime. We have to limit as much as possible. And in this case, we are passing category in which, or environment in which, the application need to run as argument, and then we are loading all the runtime properties using config parser. quite often this config parser can go up. The application.properties file can go up to hundreds of properties also in a complicated application. Okay, so let's move on to the big data, because if I have to do these things, it will take almost today. And also I want to stop this Windows machine so that I can sustain for another 1 hour to take this further. Once you start exploring this, if you struck anywhere, just raise the issue in discuss.itversity.com. We will look into those and we will try to come up with the solution. Okay. And also, before getting into the next topic, which is the main part of the course, let's remind you that there will be no class on Thursday US time because of the Thanksgiving week. So this week we will only have 3 classes: Monday night, Tuesday night, and Wednesday night in US, Tuesday morning, Wednesday morning, and Thursday morning in India. Okay, so that being said, now let me go to the next course, which is Apache Spark using Python. So this is the URL. For our reference. If anyone still have issues with respect to installing MySQL connector, let me know. I will troubleshoot and fix those issues before I move on to the Spark using Python. Okay, so setting up environment, Spark. I hope everyone able to access. I hope everyone able to set up Spark on your Windows machines and able to access by saying, okay, PySpark is not working yet, so I will actually come back with a solution by tomorrow. But most of you actually set up Spark, but you are not able to access because of certain reasons. I will troubleshoot and fix those things tomorrow, so don't worry too much about it. For now, just to make sure that everyone have access to the gateway node. Have you taken care of giving access on GW02? Yeah, you have to. I told you last week itself. So these guys did not work on setting up the environment for all the folks on gw02.itverse.com. What is that? Okay, we have to wrap it up. By tomorrow, everyone should have access. Okay, so you should be able to access gw01.itversity.com from your PCs. If you could not, let me know. I will troubleshoot those issues and we will take it further. Radhika, are you able to access the lab? Okay, cool. Okay then, so let's move on. So today we'll not be using a lot of Spark. There are other things which, I mean, at least we will not be exploring hands-on. We will be starting from tomorrow. So don't worry too much that you will not be able to access gw02.itwork.com or not able to start PySpark on the lab. We will be covering different topics today. I have already covered how to use labs, so I'm passing it on. So next thing is, let's focus on architecture of Spark. Okay, so you will not be able to digest everything straight away with respect to architecture of Spark. Don't worry too much about it. We will come back to this diagram several times later. And before we conclude the core Spark stuff, we will be able to understand what this picture is all about. Okay, so first let us try to understand the architecture of Spark. So let's say I'm already on the lab, okay? And let's say I launch PySpark, and here, whenever I launch PySpark on the lab, I will be using this argument --master yarn and also conf spark dot ui dot port. These two are the properties which I will. These two are the arguments which I always use. PySpark --master and the value for master is yarn, and then --conf and the value for that is a property spark.ui.port equal to 12456 without spaces. You should not have spaces. There is a reason why I always use these two things. I will explain a bit later. Okay. Now, first let us understand what is this PySpark. PySpark is nothing but Python shell with Spark modules. There's nothing more than that. It's just Python shell plus Spark modules. Okay. And if you hit enter, it will launch something similar to Python shell. Okay, someone already tried to use the same port. That's fine. It automatically increment to the next port and try to run. So it will retry 16 times. By default, if I don't specify this spark.ui.port, it will use default port number 4040, and from there it will retry 16 times and it will fail after 16 times, saying that there is no all the ports from 4040 to 4055 are already in use. It will just fail. So it will just increment one number at a time and retry 16 times. If it can get one of the ports from the number which we pass up to 16, it will launch. Otherwise, it will just fail. Anyway, we don't need to worry too much about it. Okay, that is fine. Okay. So on top of Python shell plus Spark modules, if you see, there is also a web server started when we launched PySpark, and that web service is available with the name FC. FC is the web service which is launched. That's why we are passing port number, and it will be launched with that port number which it took from the command line or some other value when it retries 16 times if there is a port conflict. Okay, so if it works for the without throwing any exceptions, then the web service which is named as SC is running on port number 12456, and the host, every web service need to have the IP address, and the IP address is nothing but the server which we connected to, which is gw01.itversity.com. Okay, so SC is nothing but a web service which is running on gw01.itversity.com, and then port number is some 1245 or as it retried because you guys also have ran it. Okay, if there are no exceptions, then it should be 12456. Okay, and don't worry about Hive context at this time. For now, we'll just focus on SC. Now, if you go back to this picture, whatever is launched when we use PySpark, it is nothing but driver program. Okay, so whatever we are seeing here is called a driver application or a driver program, and you can see it has a Spark context in it, and we can see that Spark context here. So when we launch Python, it just launched PySpark. When we issue PySpark command and launch the session, it is nothing but a driver program with Spark context in it. Okay, and then there is a layer of cluster manager and worker nodes. What is this cluster manager and what is the worker nodes? That's where this --master yarn comes into picture. Okay, where is that command? --master yarn. So depending upon what we pass here, yarn, and also there is another famous framework which is called as Mesos. So MESOS, Mesos. So these two are the frameworks which we typically use in production. Okay, either Mesos or Yarn. In this case, we are running on Yarn. So depending upon the framework we are using, the terminology for cluster manager and worker nodes will change. Okay, so as we are using Yarn, here we have to understand what Yarn is, and from the Yarn context, we need to understand what is the cluster manager and what are the worker nodes. Okay, so if you go back to if you go to the Ambari, so now I am connecting to Ambari. If you go to Ambari, and let me use this one only, and login. Okay, so this is our Ambari, and you can see there is HDFS, there is Yarn, so on and so forth. And if you click on hosts here, we have some nodes which starts with WN, which stands for worker nodes, and some nodes which start with GW, which starts with which stands for gateway node, and NN for name node, RM for resource manager, etc. So here, the worker nodes, what you are seeing, are referred as part of this diagram. So there, on the worker nodes, wherever we, whatever nodes we configure as worker nodes in our cluster, on them, when we launch the Spark context, there will be something called executors. Okay, so how to get that information? You can go to gw01.itverse, yeah, gw01.itverse.com, which is nothing but the host on which the driver program is running. And then I have to get the port number. So let me check the port number on which it is running. This is 12457. I think let me try 12458. 12458 and hit enter. You can see here, because the session is active, you can see something called Spark UI. Okay, and here, if you look at the picture, we are talking about executors, right? You can see executor here, and executor have cache and then tasks, and we will see what is cache, what is this task a bit later. Okay, and now if you click on executors, you will see there are two executors, one on worker node 05 and the other one on worker node 01. You can see there are two executors on worker node. So by default, it will create two executors. And these executors will actually fork tasks when we try to execute the code. So once we develop the code and when we start executing the code, these executors will fork the tasks, and these are the ones which will actually process the data. Executors themselves will not process the data. The tasks which will be forked under the scope of this executor will actually process the data, and we will see that a bit later. So you can see worker nodes are nothing but whatever worker nodes we have configured, whatever nodes we have configured as worker nodes as part of our cluster, and there you can see the executors. And then to coordinate everything from this, there have to be a manager, and where this manager is. So that manager, you can go to something called rm01.itverse.com, which is nothing but resource manager. And I will be covering the overview of Yarn a bit later, and you will understand these things in detail. Okay, you can see this is the application which is started by me, and here you can see something called application master. And this is what your cluster manager is. And again, if you click on the application master, it will take you to the Spark UI only. If you click on this URL, but if you click on this, sorry, I clicked on the wrong one. If you click on this, it will tell you where this application master is running. It is running on W104. So you can see two executors, W101 and W105, and one application master running on W104. And this is nothing but the cluster manager. So when I launch PySpark, okay, on worker nodes, it has created two executors. And on some other worker node, it has created something called application master, which will act as cluster manager. Okay, so these will take care of execution of your programs. Now, if I try to uh, run this simple Spark code, okay, let me see. Okay, this is the Scala version. I have to change it to Python version. I will take care of it later. It's pretty straightforward to change from Scala to Python. For now, I will just execute from here. So this is the input path from which I want to read the data. And then here I'm just demonstrating a simple program to get the word count. Don't worry if you don't understand too much about, don't worry too much about it if you don't understand. Let me show you how I can get the word count. So text file, input path, okay, dot, flat map, lambda, line, line dot split. This is the delimiter to get the word count. Here I'm just writing the word count program, lambda word comma 1, and then reduce by key, lambda t comma v, t plus v, and hit enter. Okay, I know the problem. It is actually, let me exit from here. Hadoop FS - put / users. Okay. Okay. The path is incorrect. Here. Yeah, so this is the path. I have to use this one. Yeah, now I understand where the problem is. On the lab, I have to use this second one. So it is launched. And let me say input path equal to and then let me copy paste this code. Okay, still I think there are some addresses already in use. Let me do this. Let me exit from here and use some other unique port number. Avoid any confusion. 315. So the 5-digit port number which you should use is between 10,000 and 65,535. So if you do not remember the port number which you are trying to use, you can also use this tracking URL, which will be built based on proxy. You don't need to remember the port numbers. You can just use this tracking URL and hit enter. Okay, and then it will take you to the web UI. And now executors are running on W105 and W103, which is different from what we have seen earlier. Okay, and then let me take that program which I tried to run earlier. Oh my God, 1 minute. Okay, file, new file. And the path is, yeah, Shivangi, let me share that URL with you. And copy this path, paste this, and then we can escape by using backward slash in Python. I'm doing that here. And then I'm saving the output to user D Gadiraju code count. Okay, so now let me run this code. Hmm? Yeah, okay. Input path came twice. Okay, so let me run this code. And you need to have lab access to run as is. I will paste this in the chat if it works without any issues. Yeah, it is working without any issues. Let me paste this code also here. Yeah, thank you, Shaili. So this is the code. Don't worry too much about interpreting the code. You can just run this. Don't run it right away, because if everyone try to launch the session and run, we might run into some some resource contention. So just bear with me. Don't do it right away. Okay, now you can see that it is processing the data. Now, if you go back here and actually look into this web interface and click on jobs, you can see the job is being executed. Okay, and when the job is being executed within these executors on W103 and W105, you will see the tasks to process the data, and that information you can click on jobs, click on save as text file, and this job URL, and then there are two stages. Click on one of the stages first. You can see the representation of how it is being executed here. We will get into those details a bit later. For now, you can primarily focus on how many tasks are created on each of these under each of these executors. So on W105, in the executor which is created on W105, 5 tasks ran to process the data, and here it ran 4 tasks. Why 5 and 4? Those things we will see later. But for now, just to understand this diagram, each executor will when we submit the code, each executor will fork tasks, and the tasks are the ones which will process the data. And there's a reason why they have mentioned two tasks here. By default, at a given point in time, within an executor, it will try to run two tasks. That's why it is showing two tasks, but you can play with those numbers. You can actually increase the number of executors and number of tasks within the executors depending upon the amount of data you are trying to process. And I will show that a bit later. Okay, for now, when I say PySpark and launch the session, it have created the driver program. And as part of that driver program, there is a Spark context, which is nothing but a web service running on a IP address and port number, which will actually create two executors even before we start executing any code. And those executors will be ready to fork the task to process the data whenever it encounter the code. And to coordinate these executors, there will be a cluster manager. And the terminology for worker nodes and cluster manager will change depending upon the framework which we are trying to execute. If it is yarn, um, the executors will be created under something called node managers. So node manager is nothing but a software which is running on each of these worker nodes, and the cluster manager is termed as application master. Okay, so that is how the resources will be allocated for your Spark application. Don't worry too much if you do not understand completely at this time. We will actually get into those details as we proceed further, and you will understand this diagram by the time we wrap up the core Spark related topics by next week. Okay, now let's get into the next topic, revision of Python. Okay, so just make sure you go through this and recollect, and the primary emphasis should be on the collections. The reason is Spark is nothing but APIs on distributed collections, and that distributed collection is termed as RDD, which is nothing but resilient distributed dataset. So if you are familiar with collections, if you are comfortable with collections, the major difference between typical Python collections and Spark RDD is distributed. List, dict, and set are linear collections, whereas RDD, which is nothing but a Spark based collection, is a distributed in-memory collection. We will get into those details a bit later. For now, just before jumping on to Spark, if anything has to be revised from any programming language that is supported, it should be collections. And you should know operations on collections. You should understand tuples. You should be very comfortable with string processing. And then the APIs such as iter tools, pandas, etc. on top of collections. So these are the important things which you need to recollect. And I hope you guys are comfortable with these things. And that's why I have spent enough time on all these areas. So we will get into those in a moment, Sumit. So don't worry too much about it. Your question will be answered very soon. So next thing which you need to understand after revising Python is file systems overview. So Spark itself doesn't have any file system. Okay, there is no file system at all with respect to Spark, but it uses HDFS API. HDFS stands for Hadoop Distributed File System, and there are a bunch of APIs to deal with HDFS. And as Spark uses HDFS APIs, whatever is supported by HDFS API are automatically supported by Spark. And now we need to understand what all different file systems HDFS API support. HDFS API support HDFS itself. It support S3 and Azure Blob. Okay, so all these cloud-based and distributed file systems are supported using HDFS APIs. As Spark understand those APIs, automatically Spark will be able to interact with those file systems, and you will be able to process the data. And more importantly, we should be very comfortable with HDFS. Others are not that important from the certification perspective, but whenever you get onto the project, if you have to read data from S3, you should understand how you can do so. Okay, so typical job cycle, we read data from one of the file systems. It could be local file system, HDFS, AWS S3, etc. Process data using transformations and actions, and write data back to one of the file systems. Okay, files from local file system can be read only when job is run in local mode. So on top of Mesos and Yarn in development environment, at times we also try to run the jobs in local mode. Okay, when you run in local mode, you will be able to read the files that are residing in local file system also. But when you are running on clusters, you will not be able to read files on local file system directly. You have to first use Python APIs to read from local files, and then you have to convert that into Spark based RDD, and we will see that thing later. Don't worry too much about this statement at this time. And then files from HDFS and other supported cloud-based file systems such as AWS S3, Azure Blob can be read in all execution modes, which is local, Yarn, and Mesos. So HDFS API is part of org.apache.hadoop.fs package. Okay, it not only facilitates from different file systems, but also can process different file formats, which is text file, sequence file, etc. So there's a difference between file system and a file format. Okay, file format is PDF, MP4 to listen to store the songs, ISO to store the installables, Doc to store Word documents, PPT for presentations, Excel for spreadsheets. These are all file formats. Okay, so HDFS API not only facilitates files from different file systems, but also can process different file formats such as text file, sequence file, and there are few other file formats which can be processed using HDFS API out of the box. If you have to process any custom file format, for example, if you have to process PDF file formats, it is a bit difficult. You need to go through Adobe support and see if there are any APIs that can be integrated with existing HDFS or MapReduce, and you have to plug in those binaries, and then you should be able to process. Otherwise, you will not be able to, or you have to come up with your own programs. Okay, we can check for existence of files, create files, delete files using HDFS API. So I will actually touch base those HDFS APIs shortly. HDFS as a file system, it's a distributed file system, and the block size is by default 128 MB, and replication factor is by default 3. And we will see those things in a moment. So now let's get on to the demo. Okay, so I'm coming out of this Python driver program onto the gateway node. Now I am on Linux terminal without any software-based CLIs. Here I can run this command line utility called Hadoop. It takes one argument called FS, and if you say Hadoop FS, you can see all the other commands which can be passed as control arguments under this. So this is the usage. So all these arguments, control arguments, can be used to interact with HDFS file system. So if you recollect Linux, and if you want to interact with Linux file system through terminal, you can use commands such as ls to list the files. You can use -l to get to the to sort the data using timestamp. You can use t and all those things. So ls-ltr is the command used to interact with Linux local file system. Okay, if you have to create the directory, you can use mkdir and directory will be created. If you want to create empty file, you can say touch and empty file will be created. If you want to delete a file, you can use rm. If you want to delete a directory, you can say rm-r rfr. I think there's a command called rmdir also. So like this, there are a bunch of commands in Linux which can be used to interact with the file system. Same is the case with Hadoop FS. So to interact with the files on HDFS, we have this Hadoop FS. Okay. So, and if you look at the commands, they are highly influenced by Linux-based file commands such as cp for copy, ls to list, mkdir to create the directory, so on and so forth. So these Hadoop FS commands are highly influenced with Linux, but at the same time, the syntax is significantly different from regular Linux commands, and you will understand that in a moment. Before getting into demo and start understanding these Hadoop FS commands, let us understand Linux file system a bit in detail. Okay, so Linux file system starts with root. What is that root? Root is nothing but the forward slash. I'm talking about file system, not user root. File system root is represented by forward slash. So this is the root of the entire Linux file system on a given machine. Okay, and from there, so if I want to go to the root directory, I can say cd space forward slash, and it will take me to the root directory. And from there, you can see by running ls-ltr all the directories that are available on the root. So we have home, etc, run, dev, etc. So you have bunch of directories and files under this, and then you can navigate through the file system to whatever directory you want. Okay, here the main point is forward slash is the root file system on a Linux based machine. Same is the case with HDFS. HDFS also have a root file system which is forward slash, but you cannot go to the directory. Unlike local file system, you can go to whatever directory you want. In this case, let's say I want to go to home. I can say like this, and then I can do ls-ltr, and whatever is there under home will get it. And then I can go to another directory. So I can change from one directory to other directory using cd command. But in HDFS, which is a distributed file system, you cannot do that. Always you have to use your forward slash to access the files in HDFS. Okay, so forward slash is the root file system. As I cannot issue commands such as cd and all, always I have to start with Hadoop FS and give whatever command I want to list the files. ls is the command, and if I say Hadoop FS -ls forward slash, it gives all the directories that are there in that root file system. So one of the directory which you should be interested in is public. And if you look into this, it is similar to Linux files and directories. You have the you have a flag which will tell whether it is a file or directory, and then you have owner permissions, you have group permissions in this octet, and you have permissions for others in this octet. So who is so for this public, the owner is HDFS, and HDFS have read, write, and execute permissions. Group also has HDFS. As the owner name and group name is different, they are same. Most likely, there might not be other users in the group, but sometimes if there are other users in the group, they have this read and execute permissions uh, on this directory. And anyone other than the owner and group or the members in the group have read and execute permissions on this public directory. And if you look into Hadoop FS-ls/public, we have bunch of directories here: cards, crime, hr_db, nysc symbols, outbrain, random text writer, read_db, so on and so forth. Okay, and you can see that everyone have read and execute permissions. Only HDFS have write permissions, which means these are open to public for read. So if you want to write MapReduce programs on heavy volume data, I will place them in public and you can process. Otherwise, if everyone try to create huge volumes of data, the cluster will become a bit unmanageable. That's why I try to consolidate all data sets as well as some bigger data sets for exploration purposes into this slash public, and everyone will have access to this. Now you can, all of you can actually log in and run this command Hadoop FS-ls slash public, and you will see all these directories. Okay, and also there is something called home directory in Linux, and by default the home directory will be slash home slash whatever OS username you are trying to connect to the Linux machine. In this case, the OS username is this one. So this is my home directory in Linux. Okay. When it comes to HDFS, there is no concept of users. It's just a file system. You can actually access the files, but you cannot actually create users in HDFS. It is not possible. Okay. Whatever you are seeing here are not users within the HDFS. HDFS is just a file system, whereas Linux is a operating system which includes file system plus users plus so many things. As HDFS is just a distributed file system, you cannot create users directly. Okay, there is an indirect representation of users. That is the users which are present on the machine from which we are trying to copy the data. So here HDFS is the user in the local file system which have permissions to this HDFS location. It is a bit confusing. You need to practice to get these things clarified. I will not spend too much time here. What you need to understand here is all of you will have a user space. As slash home slash dgadraju is home directory for you on Linux OS. On HDFS, every one of you got a user space, and that starts with slash user. So slash user is similar to slash home. And then in my case, dgadraju is the directory. And I can see all my files here. So for you, you need to run Hadoop FS-ls slash user slash your user ID. And most likely will not have anything here. It will be empty. Okay. And as a dgadraju, if I try to access some other users, I will not be able to, because by default we'll give only read permissions. So we will not give any permissions to other users. You can see the permissions here. So let me take this Zooms Kumar as a dgadraju. If I try to read Hadoop FS-ls user Zooms Kumar, okay, and hit enter. It says access denied. I don't have permissions on this directory. It will be the case with you also. So all of you can either access stuff under public and some other directories such as temp, etc., and then your own directory or user space. So this is the playground for you. You should be able to copy data here, and you should be able to access. So that is about ls command. Now let us talk about few important commands. So to demonstrate these things, I will primarily use public cards. You can see there is a 700 MB file in this, and it is under Hadoop FS-ls slash public slash cards. So let me first create a directory. So to create the directory in HDFS, I have to use Hadoop FS -mkdir, and I want to create in my user space, which is user dgadraju HDFS demo. Okay, and hit enter. For you, you need to change this one to your OS user ID. Then only it will work. Okay, so now the directory is created, and now if I say Hadoop FS-ls user D Gadraju, there will be additional directory called HDFS demo. And if you look at the behavior of ls, it is so it is behaving something like this, ls-ltr. If I just use Linux ls, it will only list the directories and files like this without any properties. If I have to get the properties, I have to say ls-l. If I have to sort the data by time, I have to say t. If I have to sort in, reverse order, I have to say ls-ltr. Whereas with Hadoop FS-ls, the data is already giving the properties for our files, and it is sorted based on name. So it is behaving as if we have run ls-l command on the Linux. Okay, so this is the default behavior of ls command in HDFS when you use Hadoop FS-ls. And already we have seen mkdir to create the directory HDFS demo. Now let's say I want to copy the data from this public cards. I want to copy the data to HDFS demo. If I want to copy the directory, I can give the path of the directory and give the target location, and the entire directory will be copied. And what is the command to achieve that? We can type Hadoop FS and hit enter. You can see the set of commands. I would highly recommend you to go through these commands and try to understand as much as possible. I will only cover some of the important commands. I have already spoken about ls and mkdir. Now to copy the files, there is a command called copy from local. Okay, as it is obvious from the command itself, copy from local means copy files from local file system into HDFS. That's why after these additional optional control arguments, the source is represented as local source, whereas with the destination, it doesn't say anything. It just say DST, which means the target is HDFS and source is local file system. Okay, so if I have to copy data from local file system, I have to use copy from local. To demonstrate this, on top of public, which is HDFS location, I also have some files on local file system, which is this one, /data is local file system. And in that, also I have similar data sets. You can see cards and many other things. You can see large deck.txt and small deck.txt. All these files are available on the local file system also. So if I have to copy from local file system, I have to use copy from local. If I have to copy from HDFS location, which is /public/cards, there is a command called -cp. So you have to be familiar with these copy commands, especially from the certification perspective. You should know how to copy from HDFS location to HDFS location using cp command, how to move using mv command. This is from HDFS to another HDFS. From local to HDFS using copy from local or put. Put is alias for copy from local. Similarly, you should know how to get from HDFS location to local file system. For that, either you have to use get or its alias copy to local. So these are the commands which you should be familiar with. Okay, because as part of the problem statements at the time of certification exams, they might ask you to copy files from local file system to HDFS, HDFS to local file system, and all those things. And you should know how to do that using these simple commands. That being said, first let us try copying files from the local file system data. And I want to copy only this file into this location, user D Gadiraju HDFS demo parts, and I just want to copy one file, large deck.txt. So I want to copy file from local file system data cards largedeck.txt to this HDFS location. Okay, that's correct, Sumit. Get and copy to local are same. Similarly, put and copy from local are same. You can actually make a habit of getting help by saying Hadoop FS hyphen help and get, give the details. Okay. Similarly, if you say copy to local, identical to the get command. There is a very small difference which I could not remember. Other than that, rest of the stuff is same. You can actually Google it. Anyway, that's not that important. That difference is not important at all. That's why I didn't try to remember that. Okay. So make a habit of using hyphen help on the commands. And there are only 35 commands which you should know to master HDFS. Okay. So that being said, now let me copy file largedeck.txt and largedeck.txt to /user/dgadraju HDFS demo parts largedeck.txt. Okay, so this is what I have to do. So if you see, if I say Hadoop FS copy from local output, you can use either of them. If I say data cards and give this path, what will happen is the cards directory will be created here. So both you will get both largedeck.txt as well as smalldeck.txt, which I don't want. I just want to copy largedeck.txt. Okay, so if I have to do that, it's a two-step process. First, I have to create a directory mkdir /user/dgadraju HDFS demo /cards. First, let me create this directory. And now I can say Hadoop FS hyphen put or copy from local. I can use either of them. So in this case, I'm using put data cards largedeck.txt. You can also use patterns, something like this. And then give the target path dgadraju HDFS demo /cards. And we don't need to give names unless the target name is different. You can just say /dot, whatever names we have on the source files will be used to copy to the target location and hit enter. Now you can say Hadoop FS hyphen ls. And you will see largedeck.txt file here. And you can see the file size is 700 MB. Okay. And if you want to just copy from HDFS location, which is under public parts largedeck.txt to /user/dgadraju/HDFS demo /cards /largedeck.txt. The steps are almost same. If you have multiple files, you have to first create the subdirectory by name cards and then run command -cp rather than copy from local. You just have to use -cp. You can also use move mv to move the files. It will delete from the source location. It will actually move from one location to other, but that requires the right permissions on the source. As you have only read permissions on public, if you try to move, it will fail saying that you don't have enough permissions. So that you need to understand. Okay, I will not be running cp command now to copy from this to that to demonstrate. It will work. You can give it a try, and if you have any issues, you can let me know. Now we will actually get into the details about how this file stores will be stored in HDFS. Whatever you are seeing here, and it's very important, please follow carefully. Whatever you are seeing here is just a logical name. Physically, it will be stored in a different manner. If you think about your regular files, for example, let me go to my Mac file system. Okay, if I go to documents and see the files, all these files will be physically stored with these names. And a name is nothing but a pointer to the byte address of the file. And if it is 1 GB file, in my 500 GB hard disk, that file will be copied in one location, which will take 1 GB of storage. And the beginning of that file will be stored in a file system table, which is nothing but pointer to your file. If it is 10 GB file, it will take 10 GB contiguous storage on hard disk. If it is 100 GB file, it will take 100 GB contiguous storage on the hard disk. So there is a command in Mac which will give the capacity on the file system, which is nothing but df. So if I say df-h, which is nothing but it will show the file system details in readable format. My overall size of my hard disk is 466 GB, and available is only 81 GB right now. But even if I try to store 10 GB file, even though there is 81 GB, still it might fail. It is typical even in Windows. The reason why it might fail is even though there is 81 GB storage on my hard disk, there might not be 10 GB contiguous storage. As my file is of size 10 GB, even though there is 81 GB storage on the hard disk, um, as there is no contiguous 10 GB storage, it will fail. It is called as fragmentation. I hope everyone heard about the fragmentation and defragmentation. So what we will do typically in Windows, we will actually run the defragmentation on the hard disk, where all the files will be moved, and make sure that you have fewer fragments of the storage to accommodate a bit larger files. Once we defragment, probably we might be able to store that 10 GB file when 81 GB storage is available. Otherwise, we might not be able to. So those are the side effects on typical file system. Okay. Even let's assume that that issue is not there at all. At max, in this file system, I can go up to 466 GB file. Let's say you have two hard disks mounted on your PC, or you have two partitions of a given hard disk, and each partition is 128 GB. So you cannot store more than 128 GB file on any of those partitions. It is not possible because you need to allocate contiguous amount of storage on the hard disk. That's where HDFS differs from typical file system. HDFS, as it stands for Hadoop Distributed File System, it will try to divide the file into something called blocks, and those blocks will be stored on the multiple nodes in the cluster, which are called as worker nodes, where data node process will be running. So let's start with Ambari here. Okay, so I click on Ambari, go to dashboard, click on HDFS. You have name node, you have secondary name node, and you have data nodes. Okay, and the data nodes are running on WN01 through WN05. These 5 physical servers, which are represented by WN01 through WN05, are categorized as data nodes, and these are the nodes which will actually store your files. And how those will be stored? In our case, I'm connecting to the lab again. So CD data parts, we have this 700 MB file, and we try to copy into HDFS. On local file system, you need to have 700 or 720 MB contiguous storage, contiguous capacity on hard disk to store this file. Whereas in HDFS, there is a concept called block size. Okay, and by default, it is 128 MB. So instead of storing largedeck.txt as is into the hard disk, what it will do is it will break down this large deck into blocks of size 128 MB. As it is 720 MB, okay, there will be approximately 6 blocks, which will be 128 MB. If it is exactly 720 MB, it will be like there can be 6 blocks, which is close to 128 MB. If it is, let's say, 1 GB plus 100 MB, 1 GB means 8 128 MB blocks plus another block for that 100 MB. So 1.1 GB file will be stored in 9 blocks. 8 blocks will be of size 128 MB, and the 9th block will be of size 100 MB. And those will be distributed on all the nodes in the cluster. Okay. So in this case, there will be approximately 6 or 7 blocks, and these 6 or 7 blocks will be distributed on these worker nodes. And there is a very clean way of getting the information. There is a very clean way of getting the information. I will come back to those questions in a moment. Some people have questions. I will answer those things in a moment. So to get details about the blocks, there is a very nice command called HDFS FSCK. I will paste that as part of the chat in a moment. HDFS FSCK. It takes the path. So already we have copied data to this location, user D Gaji Raju, HDFS demo, parts, and large deck.txt. We can give the fully qualified path of the file. And then we can say files. So if it is a directory, just to get the list of files, we can say files. To get the block level details of each file in the path, we can say -blocks. So to get the details about the blocks, you can say -blocks. And you can see this file is divided into 6 blocks. This is the index of each file. Each block 0, 1, 2, 3, 4, so on and so forth. And you can see the first 5 is approximately 128 MB, and the last one is only 50 MB. So 720 MB is not 128 times 6. My math was incorrect. So these 5 almost get 640 MB, and the rest of the 60 MB for 720, 726, 663, 168 bytes means it's approximately 700 MB. That we can actually say ls-lhtr and hit enter. It is actually 693 megabytes. Okay, so these 5 will cover 640 MB, and this one is approximately 53 MB, the last block. So these are the blocks which actually store the data. So our one file is divided into 6 physical blocks, and these 6 physical blocks will be stored on multiple nodes on the cluster, and those nodes can be retrieved by saying -locations. Blocks will give the block IDs and other details, and locations will give where each of these blocks reside. You can see the IP addresses here, and you can see there are 3 copies for each block. That is primarily for the fault tolerance and reliability purpose. Each block will be having 3 copies because there is another property called replication factor. Block size is the one which will divide your file into blocks, and replication factor is the one which will create copies of your blocks, so that even if one of the nodes goes down, still there won't be any impact on the HDFS. It's primarily to get reliability on your data. Okay, so block size and the replication factor are key. Now let me take the questions. So the first one is I don't know why it showed 2 when there is only one question. I answered Sumit's question already. Get and copy to local or same. Okay, Ashok actually typed the question and then question mark. That's why I saw 2 in the chat. So is it mandatory to have 128 MB block size? No, it is not mandatory. We can actually override these things. And I will show you how to do that in a moment. It is not mandatory to have block size as 128 MB. Now, all these are block size, replication factor. No, there won't be any remaining space on the block. The block size only takes 55. The final block only take whatever is the remaining after dividing the file into 128 MB chunks. The last block will only take 55 MB in this case, or 53 MB in this case. It will not take 128 MB and only occupy 53 MB. There won't be any remaining space on the block. Okay, so instead of having one file being stored into file system, we have 6 physical files representing one file which which is actually distributed on multiple nodes in the cluster. No, there won't be any wastage at all. It's exactly 55 MB file. So I will show you probably. Let me connect with another session. Shell new tab. Okay, SSH training at this one you will not be doing. You will not be able to do. You don't have permissions to do what I'm trying to do right now. I'm just getting into that node where that 6th block is there, just to show you how it will be stored. Sudo su root which root at. I need to get the details about the 6th block. 6th block is in this. One of the copies in this node. So I'm getting onto that node. It's WN01. Okay, let me go there and then find name. IPF. Okay, so let me go to this directory. So here I'm accessing the same file from the from OS commands. Here I'm not issuing any HDFS commands. Okay, go to this location. Okay, ls-ltr and hit enter. You can see This is the physical representation of that sixth block, and it took only 53 MB. Okay. So internally, your one file is actually divided into 6 files, which are represented as blocks from the HDFS perspective, and those blocks will be stored in the hard disk. And you can see the size of this sixth block is only 55 MB, not 128 MB, which will only which will take 128 MB and store 55 MB into that. Whatever file that is created to represent that sixth block is actually taking only 55 MB. Is it clear? No. That 128 MB is the maximum size, not that every block will be of that size. So block is nothing but a file. Okay, and 128 MB is the limit, the maximum limit of that file. Okay, so yeah. So Praveen is asking, what if a line of the file gets divided in between the blocks because of the size limit? A very good question. It all depends upon the types of files which you are trying to copy. HDFS is smart enough to support the file formats such as the sequence file, text file, etc. To store certain metadata and then preserve the information. It might have to read a couple of blocks sometimes in some cases, and it will take care automatically. But if you are using any custom file formats, that custom file format provider have to provide the logic to divide the data to support this distributed nature. Okay, that is to answer Praveen's question. That being said, now let me come back to this. And now let me get on to a very important topic, which is nothing but properties files. Once I show the properties files, I will wrap up for today's session. So if you are familiar with any software, even with respect to media player, okay, if you go for custom configuration rather than typical installation, if you go for custom installation where you set the memory settings, the directory from which where the songs have to be stored, or songs have to be loaded by default, the extensions which should be played automatically, all these control the runtime behavior of your software. And even though it is hidden from you, all this information, when you try to perform the custom installation, uh, they will be stored in some properties file. It is with respect to any software. You take Oracle as a database, you will have properties file. You take WebLogic as the application server, you will have properties files. And the way properties are presented might be different for each software, but any software will have a properties file for the configuration of your software. And in this case, HDFS is nothing but a software which have name node, data node, etc. So all the properties with respect to HDFS will be in this location, etc Hadoop conf. Okay, and in this there will be two files which is highly relevant for HDFS, which are core site.xml and HDFS site.xml. Okay, so core site.xml will have global properties, which is not only used by HDFS but also other tools which uses Hadoop cluster. So name node web interface, name node UI, and all will be part of core site.xml. You can see here fs.default.fs is the one which will tell where your name node is running. Name node is nothing but a web service running on IP address and port number, and that information can be retrieved using this. And I will explain further in tomorrow's session about name node. All the data node related properties are typically under HDFS site.xml file, and you can see there is a property called dfs.replication, which control how many copies each block should have by default, and also block size. which is 128 MB by default. If you want to change these properties, you can do that. So here I am deleting that file rm user dgadiraju parts and then sorry, HDFS demo and then cards and then large deck.txt. Let me delete it and let me copy once again. Put. Okay. In this case, I can say -d dfs dot block size as 64 MB. So let me take half of this value. 60108.864, 60108.864. Six. I don't know why it is not. Some keys are not working. 67108.864. Now I am setting it to 4 MB. And also I can say dfs dot replication equal to 1 and hit enter. Okay, so I have to first give these generic options and then use put. Okay, so let me copy this one for you and paste it in the chat. And that's what it will take care. All the supported file formats, it is smart enough to take care. If you have one single line, and unless you read the entire line, and if that one line is 1 GB, unless you read the entire line as part of your program, there won't be much of impact. Okay, so many of these scenarios will be taken care automatically. But as part of at the time of processing, if you try to process 1 GB worth of data in one shot, which is only one line, and if you are trying to read the entire line, then probably only one task will process the data. It will not be distributed. Okay, so that's but when it actually save the data, it will break into exact 8 blocks with 128 MB each, and it will know where it actually broke into broke the line, and it will take further. So it is not an issue while storing the data, but while processing, yes, there could be some problems. Okay, so that being said, okay, I didn't copy the entire path, enter command. Let me copy this enter command. Okay, yeah, so this is the command which you can use. Now the block size is only 64 MB and the replication factor is only 1. Now if I run this Hadoop FS, sorry, HDFS FSCK command on this file, now you can see that there are 11 blocks and the replication factor is only 1, and it is represented is only one of the worker nodes. Each block is stored in only one of the worker nodes. This is how you can extract the details about how your file is stored. And the most important internals which you need to understand from HDFS is replication factor or replicas and the block size. Only these two things. You don't need to worry too much about other internals. These two things are very, very important as a developer. Okay. So that being said, we'll wrap up for today, unless you have any questions. and we will continue further on the file system commands. And then I will cover some important topics such as name node, etc. And then we will see overview of yarn. Then we will get into the PySpark and other details. Any questions here? And from the certification perspective, you just need these things. That too for HDPCD Spark or Cloudera certifications. For Mapper or really Spark related certification, I don't think there will be any emphasis on HDFS related stuff. Then you don't need to worry much about it, but you should know that Spark runs on HDFS, Azure Blob, Amazon S3, etc. There can be a question in Aurelie or Mapper certifications about types of file formats which are supported, and you should know what all file formats are supported by Spark. But from Cloudera or HDPCD Spark certifications, you should know how to load data into HDFS because it's scenario based, and they might give a question where you have to load data into HDFS and then process it. And also having this knowledge of the impact of block size and replication factor will definitely help in many ways at the time of working on projects and other areas, facing the interviews, etc. Okay. It seems there are no questions, so we'll catch up tomorrow. We will be covering yarn also, and we will revisit the architecture once again after talking about the yarn with respect to Spark, and it will start making a bit more sense to you. Even then, you might not be able to understand completely. As we proceed further, as we see those details when we actually run the jobs after coding, everything will start making sense, and you will understand this very important diagram without any questions. Architecture of Spark. You should understand this diagram. It's a very, very important diagram. Okay. Okay, then see you tomorrow. And those who joined from YouTube, thank you very much for joining the session. And as you guys are aware, this is primarily backup for my live audience. In case if you have any questions, you can write those questions on discuss.itvarsity.com. If you want to practice the way I'm demonstrating, you can sign up for the lab in using labs.itvarsity.com. And if you like the content, please click on the like button. It means a lot for us. If you want to share with your friends, please click on share and let them know that about the content. It gives us enough traction, and we will try to come up with more and more content like this. Okay. That being said, we will be getting into Spark, and next 2-3 weeks we will be predominantly covering Spark. And to practice Spark and Scoop and other relevant topics, you need to have a good environment. If you need that, make sure you sign up for labs under https labs.itvarsity.com. Thank you. Bye.